All right. Hello, everyone. Uh, this is another long form content video. This is the first video in a series of system design videos, high level system design videos. Um, I expect and I hope that this content is very different than other system design videos in the fact that it's going to be a lot less fast paced, slower. I'm going to be doing a lot of research on the side. It is going to be long form. I'm going to try and really put an emphasis on uh, quality coming from a place of someone who may be inexperienced with the types of systems that we're trying to make. All right. With that out of the way, the types of systems in this whole series, I think, are going to be related to um, like some massive organizational platform. Uh, 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 like we'll say massive organizational platform. Um, ah, uh, so hopefully hitting on some of the hitting on some of the very common business problems and organizational problems that like every organization faces, right? So very common problems, things like inventory, time entry, profiles, documentations, managing data, very common business use cases, common things that all the businesses run into, and I keep using businesses and organizations separately. I'm trying to not say business platform and say organizations because I do think it would be good to um, uh, put a heavy emphasis on public-facing organizations that have, I think, a lot smaller or at least a lot less well-known software industries behind them, just because it's just a different market, right? So when I say public-facing organizations, like non-business organizations, I'm talking about, or at least like pseudo-business organizations, I'm talking about like hospitals, um, uh, school systems. When I type in school too, school systems, um, prisons, um, utilities, right? These are all, very common. There's hundreds, thousands of each of these types of systems. I should say hospital systems and prison systems for all of these, right? Because they're typically managed by a larger entity, right? Utility systems. But these are, not necessarily like exactly what we think of as businesses, but they are very common organizations that, are still in the market for software, and not that, I'm not even creating this software for real, right? These are just system design videos to design a platform with these types of solutions. But um, I want to have that kind of emphasis on it. And I think, why am I choosing this? Why a massive organizational platform? I think this is a very deep well, right? I mean, there are millions of video, just putting these down, right? One platform to cover all of these types of systems, and if I do include businesses on the side too, right? Um, this is, a never ending well of common business. I mean, there's probably thousands of pieces of software out there solving hundreds of solutions. Uh, there's an endless number of things to design, right? Things to design and never actually build, right? So, um, okay, so that's kind of our goal, right? Another part of this, right? When we talk about, specs, I you know, we're just designing systems here. And so I feel like there is no need to ever sacrifice like quality in favor of like productivity, right? There's no end date for this. This is a never ending series where I'm just designing things, right? So there's no, we can kind of shoot for the stars here and make it as challenging as possible to design these systems. Okay, so scale is really big, right? Whatever that means for whatever type of service we're creating, right? But I mean, I think that's where it gets interesting, right? Not just, we're not just doing one hospital, it's a hospital system, right? It's not just a small mom and pop shop, it's a major business, right? So whatever solutions that we're doing in this series, they should have a really big scale, and they should definitely be cloud-based or at least distributed in some. I'll just put distributed. I don't know that it'll actually be like a public cloud, right? Distributed. So some sort of large distributed system that's serving a lot of people, and really want to put an emphasis on privacy and security. And then I think if I go any further, I'll just be listing out buzzwords. So I won't, but whenever we do come up with the use case, I really want to shoot for kind of the stars here, because I mean this is all hypothetical anyways. This is all theoretical, and if there's going to be any enjoyment out of this or utility out of it, it's going to be getting familiar with platforms that are real world and at scale. All right, so that's to preface kind of the whole series, and now we can focus on this first video. I think, any platform that does any solution one way or another, the mark of a real platform is we've got to talk about identity and access management. Identity access management. So this is authentication and authorization, logging in for all of the different services or solutions that we might provide. And I think it's kind of central for a platform. If you're a platform, that you have some sort of central identity and access management. You don't want different applications and different services using different ones, right? So I'm talking about I should have left organizational platform up there, but in this case, we're talking about we definitely want to shoot for like SSO, right? We definitely want to have MFA, multi-factor authentication, single sign-on, right? I think those are the hallmarks of modern day identity and access management. And then, oh man, okay. Before we get into this, I also want to preface with the fact that I am not a security expert, right? I'm a software engineer, that currently works, on back-end solutions in a real industry on large products so I'm not like someone who doesn't understand anything about software. I'm not like a complete novice coming into this, but I am in no way like a security expert or a cryptographic expert, right, as it relates to identity and access management. I've never worked on any sort of identity and access management solution before, right, outside of personal projects where someone had to log in and I used like a salt and a hash or something like that, right, for their password. So my IAM and security experience, very low. Software experience, that's much greater and larger, right? So basically someone with general experience, but not, so if you're coming here to hear how an expert would design this program, that is not what this is going to be, all right? This is going to be someone Googling relatively frequently, trying to figure out what certain things are, what they mean, and how they work. Okay. But I think that kind of shows the value, at least the value I'll get out of doing this is, I really don't know much about identity and access management coming into this. I don't know how it would work, what challenges are faced by people, but I know that all the businesses out there have some sort of team or some sort of solution doing identity and access management, even when they use third parties, right? Which is strange to me. I'll say that, before we even get into this, right? Identity and access management is like a service that is provided by every major cloud provider, right? They have their own access management, and then even small sites, right? You can get a third party, so many places I don't log into anymore on their website, right? I log into my Google account or my Microsoft account or my Facebook account or something, and then that logs me in, right? Or they just rely on OAuth exclusively to get information, right? So there's this I don't know, identity and access management is now not something that everybody has to do themselves, right? And maybe that's a realistic expectation of why does my platform need to solve this problem and not just use some off-the-shelf cloud version. But I mean, the whole point of this series is right to design pieces of a platform of an organizational platform, right? And this is definitely one of those. So I'm sure there'll be many solutions on here that, of course, already exist in some form or fashion from some cloud provider or some major service provider, right? So uh, I'm not going to let that be a disqualifying factor for any of these problems. Okay. All right, with that out of the way, we're trying to design our own solution here. I think SSO is important. That's intriguing to me, and I think MFA is important. So I definitely want to let's start with those two, and let's again, let's say that this is I don't know the scale of the users, but let's say the users is huge, like in the millions, right? Like we need we need this to be horizontally scalable to the point that we could handle a ton of people constantly using this. We should be able to be the size of those third-party service uh, 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 um, identity and access management services, right? So like whatever Google or AWS are using, right? Our design should be able to, play ball with those guys. And again, I'm sure those designs are super sophisticated, but this is a high level design, right? We're just trying to get an understanding. All right, get familiar with the problems that people run into. Okay, so I think this is a fun place to start off from. I think this is kind of clean. So I think we have a couple problems here that we maybe I can define out specifically, and we can figure out how to address them. I'm going to be using Plant UML, I think. I don't know. Maybe I'll switch to another service before, but I've used Plant UML a lot in the past. I really like it. And yeah, I guess it. I think there's like 100 other services out there that'll allow you to do like a drag and drop thing, which probably is faster and easier to think about. But I think having a like a text-based description of the actual content and then the rendering happening by something else and something that's distributable and upgradable and especially unified for a bunch of different types of diagrams, I've just been pleasantly surprised in using it in the past. Also, it's pretty widespread and open source. So there are benefits there too. All right. All right. All that said, let's see here. I think, okay, we have a couple of problems that we need to solve here. So I'm going to say, first off, authentication, right? We need some sort of, actually, let's go back even further. Sorry, or back in the way that I'm thinking about it. Before we even get to authentication, right? We're going to need some sort of database somewhere with user information, right? Right. Maybe not like, I don't know if this is like some sort of master database that holds all the information for like all the services or across the platform or what kind of relevance it has in total, but we're going to need some sort of database with like generic user info, like at least username, password, everything that's going to be required to do authentication, right? So maybe this is under authentication, but we need at least some database somewhere with authentication information. And obviously that has to be, private, kept under lock and key. There's got to be some sort of heightened security on protecting this database. So let's say database with user auth info. For example, username, password. And it won't be the actual password, right? I'm just trying to add a high level here. Username, password, email, phone. Okay. Okay, so like information that could be relevant in um, providing that, and there's going to have to be some interaction with this database, right? So we're going to need to be able to add new users, right? And that'll be, add new users, and then get information about existing users. Oh, we're also going to have to delete users, right? So get information. Okay. Alrighty. So that database has to exist. Then there has to be some, server in charge of the authentication to a certain extent. This is where the MFA comes in, right? We somehow coordinate the multiple factors of authentication, right? Even if we have different, services or containers that are performing different pieces of the containerization, or even if we have all of the forms of authentication happening on a particular server, there's going to have to be some coordination within that server over these procedures. They take time, managing a session with a client that's trying to log in, right? So there's some sort of authentication that needs to happen here. MFA, I'll say MFA coordination and execution. All right. Okay, and then this is SSO, and this is the important part, right? At the end of this authentication, we're only going to perform this authentication once, and the result of this authentication, or at least one of the results of this authentication, has to be some sort of generation or token generation, or maybe not a token, but there has to be some result of this authentication, right? That I think I'm getting ahead of myself here. There has to be some sort of result. Let's not call it a token yet, or it's unclear where this result needs to be, if it's with the client, or if it's stored in the database itself, or what happens here. But there has to be some result that allows us to avoid re-authentication, at least for a time period, right? There has to be some result that is stored that lets us know that a particular client has been authenticated, and we can identify that client again without re-authentication. Okay, so we need a result that can identify client without re-authentication. And I think that's going to be huge, right? But I want to be clear on how we're doing this, right? Re-authentication. Okay, and then somewhere else we're going to have our services almost certainly running on different VMs or different containers, right? So we're going to also have there's going to have to be the service authentication. Or not authentication, but the service, I don't know, identification, service, client identification, right? When a client reaches out to a new server, right, it's going to somehow have to fall back on this result, right? Right. The service is going to have to rely on some sort of result to understand that the client has been identified and does not need to be re-authenticated, right? So that is going to be interesting. Okay, and then the next thing I want to, let's see, is that everything? I think there's one other bit to it here. I think there's some authorization here, right? Now, I'm coming from a networking world, right? So authentication, authorization, and accounting, AAA servers, go hand in hand. And I understand that we're not like describing behavior necessarily on a network. This could be over a web application. It could be on a network, right? But we do need to talk about accounting too, right? It's ingrained in me. And I think when I say accounting, okay, so obviously authentication and authorization, or okay, Authentication is platform wide, right? This is platform wide, and so is the database above, right? This is platform wide authentication, and you log in once to the platform, whatever that is, however that works, right? And then you can use all the different ones. I'm thinking about like Atlassian products, right? Or Microsoft products, right? Where you log in once, right? SSO, and then you don't have to log in when you go into the next application. There's some sort of token or cached result or cookie or something somewhere that they are able to use to identify you again without re-authentication. When you log into different services, right? Okay, now authorization is a different issue, right? Where now on each individual service, each user has different authority, right? And I don't know if that means we're going to be doing roles or groups. I feel like this is a tale as old as time, and how you define the authority and permissions of everybody using your services, right? Which definitely means that I have to design that system as part of this series. But I don't know if this is necessarily, this is definitely part of IAM, right? The access management. I think, I've been talking mainly just about identity here and authentication. Let's focus on the identity first, and then see if we can build in access afterwards, and then talk about how accounting plays into this. Because I think there's this interesting pattern where, like, obviously we want our authentication to be platform wide, but whether we want our authorization to be managed by a central application is also questionable. Like, does each service want to have its own kind of authorization, or do we want that to be global too? I think we would want it to be global. I think access would also want to be controlled by the server. But when we get to accounting, that's where I definitely feel like, I don't know that we want to have some sort of global accounting mechanism. Individual services may want to store their own account. I guess accounting may look very different depending on the service, right? Whereas authorization might look a little different depending on the service, and authentication is going to be pretty much the exact same, right? So it's like, by the time we get to accounting, I'm pretty sure this is like service specific. Or at least that's how I feel now. Who knows? Maybe we'll change later. But I feel like this is probably going to be service specific. Authorization could go either way to me right now, but I think it makes more sense to be platform wide. But who knows? Let's table these two for now. That's definitely going to be something to figure out. I think this is more than enough. I don't even know if we'll finish this today, right? We're just trying to figure this out. Okay. All right. So like I said, I am not a security expert, but I do know a couple of the terms the kids are using these days. The database with user authentication info. Is this an LDAP server? This is a lightweight directory access protocol. This is LDAP is a protocol, sorry. And S is just like the S in HTTPS. Okay. So this is just a protocol for open vendor neutral, protocol for accessing. Okay, so you would have like an LDAP server that wraps your database. The use of LDAP is to provide a central place to store usernames and passwords. Many different applications and services to connect to the LDAP server to validate users. That is actually very different from what we're trying to do. We're trying to have, is it? We don't want many different applications and services to connect to the, okay. All right, let's come back to this in a second. This is, I don't know if this is actually what we want at all, right? This sounds a little different, like a telephone directory. See, this feels very open. Like anybody can come and just check what the username and the password is. That way everyone can do their own authentication. This feels like, not single sign-on, but same sign-on, right? Where it's like, you still have to it's like I'm using Atlassian products because I'm familiar here, but like if you still had to log into Confluence and Jira and you know you still had to log into everything separately, um, but you could use the same username and password everywhere, right? Which is different than what I'm talking about, right? And maybe I should, when I put SSO on there, it's not clear. I don't know actually if SSO is same sign-on or single sign-on, but I'm talking about you sign in once and then you don't have to sign in again, right? Which I think is different than, at least maybe we can still use this protocol to interact with our database, but I think this is different than what we were talking about. Okay. Um, all right, so let's hold on this. Okay, and then the other thing I was going to look up is Kerberos, because I know that's like a big part of, there's a diagram I looked at. Yeah, this diagram here. Okay, love this diagram. I don't know who made this, but they're great. I was looking at this the other day, and it's part of what inspired me to do identity and access management first, as the first video in this series, because I knew I was going to make this series, but I wasn't sure, what I should kick it off with, and I feel like this diagram was like, whoa, I have never taken identity and access management this seriously, at least seriously enough to like understand what's going on here. Okay, so there's a lot going on here in this diagram, right? We have all these shared keys, and these are all symmetric keys as I understand it, right? And so it's like the client generates the client requests, authentication. This is like the request to authenticate. And the authentication server uses a shared client key to give a new session key. And then it also provides some information. One thing I really like about this is this idea of like different servers communicating secret information with each other without ever directly communicating with each other through the use of sending it to the client to provide. So the client never actually sees, some of the information that's coming through. Okay, in any case, I think, to be clear, I think Kerberos is mainly for network authentication, right? I mean, I'm sure there's ways to use the same sequence and the same flow for like web-based stuff and, something closer to our use case, right? But I understand it's mainly for, or at least this design is imagining you're like a new client on a network, right? Okay. But this is the one authentication that happens up here. We do this one authentication, and then when you want to connect to a service, you have you send back, some of the information that you got earlier from the authentication server that you couldn't see, and they have a shared key, right? And then, all right, that gets passed back, or the new blue key, the client session, gets passed back, and the client has the red key, right? Because that was passed using their private client key, the ticket generating server key, right? And so you get access to the blue key, and then the service server gets access to the blue key via the black key. All right, a lot of keys, good Lord. And I think more than anything else, what we're seeing here is, every server that needs to communicate with each other and needs to trust information from each other, they have to have a shared key. And I do wonder, like, how this scales. I mean, that's my first thought that goes through here. Is this diagram like, because you're not going to have one, there's no way you just have one ticket granting server, or like, okay, so first off, we'll start off. Does every service server have its own black key? Probably, right? Which makes me wonder, okay, does that mean every ticket granting server, I mean, not only does every ticket granting server have to have its own black key, but then like, it needs to have maybe, there's probably a bunch of ticket granting servers, right, that then have to have all the black keys, or maybe every combination gets its own key. In this situation where we just have one service, one client, one TGS and one authentication server, there's already so many keys, right? And these are all symmetric keys, right? Which I guess, like, I don't know enough to know why we wouldn't be using asymmetric keys for this. At least for the authentic. Like, I understand that the actual, like, the actual client key, you'd want symmetric encryption. Actually, I'm not sure if this key is actually used for the encryption itself, or if it's just used to authenticate and authorize the user. Also, I think it's interesting how the authorization, maybe there's more authorization happening here for the client server. Okay, so I think we've established that I don't fully understand how Kerberos scales, but I'm sure it does. But I think this is a lot closer to what we're trying to do than maybe. I mean, we could probably use both. They're not really solving the same problem, but okay. And then this is called the key distribution center. All right. So let's take a step back. I feel like we've already gone a little far here. Let's make our database. All right. What do we use to show a database here? All right. And we can just say database. There we go. Database. User info. All right. So we have our database with user info, and then we also need the client. Let's see. Let me show a client. Can we just say client? I'm also not sure component diagram is the best diagram for this, but I think could be good. Let's see. Components. I wish there was a big list of all the different types of components. All right, let's not try the component diagram. Scratch that. Let's try the deployment diagram. It looks like, I don't know, it at least has a ton of stuff. All right, database, looks the same. And then there was braces. Here we go. There it is. And we can say user info. There we go. Okay. So we have our user info database, and then we need our actor client. Let's see if we can figure this out slowly. Oh, can I just say user info? Oh. No, that does not work. Whoa. Oh, it thinks it's a different diagram. All right, you know what? Let's not get too crazy here. Let's follow it. I think it's actor. And then there we are. All right, so we have a client, we have our user info database. Add the word database to this. And then we need some sort of initial server. Ba, ba, ba. Person, process, package, rectangle. Let's try component. No. Node. Now let's do rectangle, at least for right now. Okay. Rectangle, rectangle, and then we'll call this. Actually, we should have like a client machine and so maybe it's a phone or something, and then a server. Maybe machine is wrong. Server. How about we just call it the server, and then there's some sort of client device. Okay. Alrighty. Oh, these are names. That's what it is. Wild. Okay. All right. So we're gonna need this at least a little bit. Let's see. How do we get our arrows? Lines. Beautiful. Okay. Define them all and then. Okay. So let me hold off for a second here. Right. So. I think these two servers are separated out to show that you could have separate servers, but I think, from a client perspective, that's not necessary. I also think that, the symmetric keys. Okay, let me preface this by saying I don't just want to get rid of the symmetric keys because asymmetric keys are better, because that's not true, right? In security, my limited knowledge of security, I know that security is all about context and there are weaknesses to everything, right? So let's be realistic here about the values. Okay. When two machines, okay, so first off, key management here seems crazy if every single pair of devices that needs to communicate private information needs to have their own pair of keys. Like, that's expected between the clients, right? That's expected between for each session we want a different key. So there's already going to be thousands of keys going around, right? So the idea that, we're going to get away from key management is kind of dumb, right? That said, proliferating and keeping track of all these private keys that are going to be reused. See, that's the thing. These client keys, if we lose a client key because it's so temporary, that's fine. But if we lose one of these server keys, that's like a little scary. And I guess you could make those keys temporary by having servers that are cycled. Like, we could cycle through authentication servers and ticket granting servers to prevent, that way they can have private keys that don't live very long. That way we don't lose too much if we lose one of them. But that seems like poor design, especially because you can't request out of all of your services. I mean, that's like it's a weird amount of overhead to say that specific servers need to go down. I mean, what if someone's in an active session and we have to take that server down? Like, we can divert traffic, but sometimes sessions last for a really long time, right? People are actively engaged in whatever they're working on, and then we have to define a handoff. It just seems like we're creating a can of worms if everything is temporary. I don't think everything being temporary is something I want to do in the first episode of designing this platform. Okay. Um, uh, so we need to. Okay, so we're talking about the pros and cons of these symmetric keys and what our downfalls are. At least in this design, before we start creating our own. Um, okay, so one thing is that there's this kind of dual authentication thing going on, right? Like in instance here, when the client server request comes in, the service server knows that the ticket granting server must have sent this message because it was encrypted with the black key, right? So that is known. And moreover, the ticket granting server knows that the only person who can read this message is the service server because I'm encrypting it with the black key. So there's this like kind of dual verification because we're the only two servers who have this key. So I know that even though I'm sending this to someone else, even though this is practically a public message that is just going out, maybe on the internet, maybe anywhere, that this is still a private conversation between us two because there's this like end-to-end encryption to it. So that's valuable, right? And that's not something you get automatically with asymmetric keys, right? Because you have a public key and a private key, and if you don't share the private keys, then, you know, and obviously you don't want to share the private keys because then it's basically symmetric keys, right? So there's an element there. Okay. Um, and that's important, kind of dual authentication. Second off, I don't know that it's necessarily important that these be two different servers, right? Like, I don't know that the client really cares whether it's the same server we're going back to for the next thing or a different server. It seems like maybe this is just like part of the design, right? To understand that there's a different set of operations happening here that are more common. Every time you log into a service, every time you want to log into any service server, you got to go to a ticket granting server first. So there's probably a bunch of ticket granting servers compared to, maybe relatively few authentication servers because the authentication only has to happen once. But authentication is probably a lot more involved. You see, like the act of authentication is probably um, a lot more computationally intensive, right, than the ticket granting server because we're really just shuffling through, handing out keys, right? Um, all right, let's think this through. Okay, whatever I end up doing, right? I don't know that it needs to be a session key, but I love the idea of my result being a token, right? I think one thing that's really cool is that these servers don't have to communicate with each other, and that is so valuable, right? I know in my previous projects there was this element of I'm keeping track of who's logged in, maybe, or it's on the server to perform that authentication for every single request, right? I know in one of my earlier projects, like in college, there was this idea of it was a personal project, but I had this whole design where every single API request was authenticated, right? And it allowed me to be to have this completely stateless design. Uh, but it is this huge overhead on every request of having to prove your identity. And I think um, having a key for one specific exchange is great. And then having another key, a session key that allows you to create specific exchange keys is, very cool. That hierarchy is genius, and I like that idea of having tokens. Okay. Uh, I like this lightweight directory access protocol. I think it makes sense. I don't want anyone using it except for whoever's doing the authentication. And that might not just be one server, right? And that's another thing. Okay, so all right, let's try. Whoa, oh, all right, let's take a step back here, right? So, um, Is it important to have a client and a client device? Let me get rid of the client for now. Okay, so the client device, client device is going to reach out to the server, right? And I recognize that I should probably say who the server is. Okay, the client device reaches out to the server, and then our server, right, probably reaches out to the DB. Actually, let's not even go there yet. Let's just say server goes back to the client device. Okay, so from a client perspective, this needs to happen, and there needs to be. I think what we really want is a token, right? Okay, I'm going to use the term authentication server. I think we're there. Okay, from the client perspective, there's an authentication server. Oh, you know what? I didn't define APIs. That could be valuable. Let's take a stab at that. Yeah. Okay. And it's not a use case diagram. I think that's how I'm kind of designing it, but it's not a use case diagram, right? Maybe I should have a use case diagram too. You know what? I will. I'll have a sequence diagram. But first, there's we need to get a better hold of what's going on here. You know what? Maybe I can start a notepad to get to there. Okay. So I'm saying that'll actually be nice. The client reaches out to the authentic auth server, and then the auth server needs to give back some sort of token. And there needs to be some sort of authentication performed. And then when the client wants to reach out to a new service, I guess, okay, here's what I do like. I like this pattern of the client reaches out to an authentication server to get authenticated. And then whenever we want to use a new service, we generate some sort of session key to use with that service. Now, I'm not sure that we actually need this middleman here. Like I said, this ticket granting service could probably be part of the authentication server. It could also probably be part of the service server. Or maybe it can, and I just don't understand this well enough, right? But at least that hasn't been proved to me yet that we need these to be separate servers. I guess these could all be the same server from the client perspective, but yeah, there's some sort of key generation that needs to happen. Okay. Let's say that there's an authentication server, and then let's add one more server here for the actual service server. I'm ripping a lot from this Kerberos diagram, but I think that's my best understanding of what's going on here right now, and I don't want to lose that. All right. Okay, so somehow there needs to be a token given back to the client so that the client can then interact with the service server and authenticate itself, right? And then this user info database. Okay. All right. I think we're just starting to get somewhere here. All right. Okay. Sorry. Thinking through. best way to write this down? Um, okay, let's say that they're not servers, and I need to stop using the term. Well, maybe I don't have to stop using the term server, but inside this authentication server, right? Um, we need some sort of service performing. I think this MFA business, right, and generating a token. So maybe I can write out a little bit of what these need to do, right? So the authentication server, we need at the end to generate a token that can be used later. Right? We need to perform MFA, right? And maybe I should define MFA a little bit here. And define these APIs. That's what I said I was going to do. Okay. All right. Okay, so like this here, the client reaches out to the authentication server, right? From the client perspective, we need let's write out some APIs here. Okay, so on the authentication server, we have an API. APIs. The first one is going to be like login. Oh, I don't know what that was. I also don't want to forget about all of this business, right? That's going to have to go through a server too, right? With people who are like, that's going to be its own bag of worms. So let's maybe just try and focus on these APIs for a second. All right, so our authentication server, right, has to have some sort of login. We're going to need, and this login, right, it'll take a username. And then I really like the idea of this being stateless. So is it possible that a single API could have the results or the proof, right? Could have proofs of multiple factors of authentication, right? So could it have the proof of a password? Could it have the proof of could it have the proof of okay, let's say it's a phone code or an email code, right? I think that counts as something you have, right? Let's do phone code. Let's hold off on email code, at least for now. Let's see if we can do just one of these, and then we can talk about others, right? So I say MFA. This is going to be 2FA for now. It's a password and a text message to your phone, right? So it's probably not possible, right, for a single API to come in and have both, proof of all of that information, right? Right? You could have a username and a password, right? But there's some sort of like, this simply generates. I'm thinking about how I log into things, right? You log in, you put in your username and password, and then it sends a text to your phone, right? So there's this like halfway point where you've provided one factor of authentication, but you haven't provided another factor. Oh, okay, so there's a layer to this, right? I mean, this is an interesting layer that is not going to be found in my Kerberos diagram. But it's nonetheless important. Okay, so let's say we have a username. okay, let's say this is like login part one. Part one, we pass in a username and a password, and then there is login part two. Okay. Okay, login part two has, and then maybe somewhere inside this API we maybe we verify password and then send text. Again, this is very high level from a user perspective. What's happening? They verify my password and then they send me a text message. And then part two, oh, see, this isn't even coming. Part two is I provide, maybe my username and text code. Right? Text code. Send text with code. Okay. All right. So this is kind of strange, right? We have this like text. I don't know why I switched my casing there. It's with code, and then they provide the username and the text code, right? And this is definitely stateful, right? Because after part one, just because somebody sends in part two with the text code doesn't mean they're the same person who sent in part one, right? So there's some sort of, I don't know if there's like we return a temporary key, right? Return temp key, right? And then we send back like temp key and text code, right? Maybe that's what I should do here. Okay, so part of me is thinking we could do this all in one. We could just have an initial API that sends a text code, and you don't have to send your password. And then all in one, we send the password, the temp key, and the text code. Right? Password. And then we don't need the temporary key. Right? We could just send in the password and the text code. Right? We verify your password, and then we send you a code, and then you send your username and password again, and you send a text code, and we authenticate that way. And all you can do when you log in part one is that we send that code we send code to the number on file in our database. Okay, I kind of like this. This is kind of nice, right? Okay, and then I think we should be a little more clear about our database design here. I feel like a lot more of the design is now happening in this text pad than in here, but we will get it into this plant UML at some point. Okay, we need the APIs at some point, but I want this user info database. We should specify a little more clearly what's in there. Okay, all right. So like okay, so this database I feel like has to be a relational database to a certain extent, right? I mean, this is just a couple pieces of information, right? This can be, I don't know, if it's SQL or what particular SQL engine is running it. That's probably for another video, right? But let's say we have a relational database here with user records. I think that's relation. Well, I keep tapping that button. Okay, relational. Okay, and we're going to have the username. It has, okay, and now here I think we do need to be a little bit more specific, right? So let's see, in our schema, there is a username, which is just text. And then we can't just have a password, right? We need we'll have an algorithm that does some sort of hash, some number of times, hashes the same password 100 times over and over again with a salt. We need a salt, and the salt is per user, right? So we'll have a salt, and then password hash, and then we need a phone number. Okay, boom, that's what we have. We have a username, a salt, a password hash, and a phone number. All right, and then APIs. We need create user. Which passes in a username. Okay, so yeah, this is the schema for the database, but like the APIs. Obviously, these aren't like SQL APIs, right? There's a wrapper around this database. There is some sort of database wrapper, right, that's managing this information. And if we're really talking about giant scales and clustering and all of that, this database is, partitioned, it's running in the cloud, it's distributed, it's running in the cloud, right? It's big, and there's multiple servers maybe that are interacting with it. So let's say that there's some sort of, I don't know that it's LDAP now, but we'll say a server, a database wrapper server, right? And this has APIs like create user, I take a username, a password, hash, and a phone number, and then who generates the salt? Where does the salt come from? That's a good question. See, I would think that we would just generate a random salt here, but the salt is definitely going to be, I guess the salt can be, maybe in here, I guess. Is that weird? I feel like maybe the database wrapper server shouldn't be doing anything cryptographic. It should really just be serving information. Yeah, I like that idea. So it's a password hash, or salt, password hash, phone number, and then get user info, right? Get user, and we pass in a username, right? And we get back all of this business. That's nice. Get user and then delete user. And again, we pass in the username. I do not know why I did that. Do this. Okay, it returns a salt. This returns nothing. And then this returns nothing. Okay. Or they can return booleans that it was successful or not. Right? That's more. We'll say, I don't know why I put a type there. It's success or fail. Whoop. All right, there we go. Success, fail. Success, fail. And then get rid of that. All righty, here we go. Okay, so we definitely got some business going on here. We've got some APIs for a database wrapper server that is directly interacting with our database. We've got this authentication server that has this part 1 login and part 2 login. And then, okay, so is this a password? Like a plain text password? That seems unsafe. Like, I remember everyone always saying, if you hash the password on the client device, then really the hash is the password. And that is true, but I think there's still value in hashing it once before you send it, right? Like, I mean, it's at least then if somebody finds it, they can't use a regular app, right? Like they would have to engineer the sending of the password. Let's say this is a password hash. Password. I understand it's just a password, but it's like hashed once. Like let's say on the client they hash the password once, and then once we get it, we add the salt and hash it 50 more times, or 100 more times, or 1,000 times, or something like that, and then we compare it to our hash, and that's like, boom. Is there also a thing like a different number of, sorry, like I know the salt is like specific to each person. Is there also part of like a thing of like the number of times you hash the password is specific to the user? Okay. During login, the password is hashed again. Yes, look at that. They hash it first, and then they well, this is an AI overview. I don't know if this is realistic, but okay, hold on. This is just about hash functions in general. Is there anything about on passwords? Yeah, here we go. Controlled access systems. Sorry, hash features. Rainbow tables. Special hashes called key derivation functions created to slow brute force searches. Slow hashes include PBKDF2, bcrypt, scrypt, argon2, balloon, an iteration count of 10. The iteration. Okay, the hash iteration count is what I was looking for. 10,000 or more. Okay, I don't see anything about having an iteration account separate for every user. And then I think the whole point of these algorithms is just that they're slow. Okay, hold on. Let's see, password hashing iteration count. Let me see if there's any value in doing like, here, look at that. NIST recommends a minimum of 1,000 iterations when I just saw in Wikipedia a minimum of 10,000 iterations. Is that not funny? Okay. See. SHA-256 good enough for password storage? Okay, hold on. Okay. So I don't see anything saying a different iteration count per ID. Okay, I guess to be fair, I'm not sure what I'm gaining by doing a different iteration count if I already have the salt, right? The whole point of the salt is that The whole point of the salt is that if the database is compromised, similar passwords do not have the same hashes. And I think that's the same thing I'd be solving by changing the iteration count. Oh, that's a good point. If you're doing it, the attacker's just going to compare each one anyways, right? There's no. Okay. I I like this. Okay, this makes sense to me. All right, so we just have a giant iteration count. Same for everyone. We don't need a special iteration count for each user. That's a good thing to know, but we do need a special salt for each user. Okay, and then you need a password to get a text, and then you need a password and a text code. Okay, one thing I do like is we send a hashed password in this one. Right? We could send a hashed password in this one too, of course. We could use a different hash. With the idea being that, like, we use a different protocol to generate this hash. With the idea being that just because someone maybe gets this hash or gets this hash, they don't know the actual password, so they can't go seamlessly between these two, right? They don't know the actual underlying password, so they're still kind of screwed. However, if this is only hashed once, that's another part of it though, right? I mean, this is only hashed once, so someone could brute force it. So are we really protecting that much? Are we really protecting anything? Oh, this is an interesting question, right? We're expecting the client now to have two separate algorithms that can hash, that they'll hash the same password with two different algorithms and send them in the two different requests. I'm not sure that does it add anything? Or do we just send the same hash now with a text code? Oh, God. I do like the different hash idea. I think it's funny, this idea that, like, someone intercepts this password somehow, and then they still have to brute force this password in order to get through. They can't just send it on the next one. It's not enough. It's not enough to take one of these. They need to also brute force it to get the other one. Which I guess anyone who's intercepting the password hash out of this, because I mean all of this is happening inside TLS, right? So I guess if they're pulling off getting by TLS, they can probably just brute force our password anyways. There's no real extra security there. Let's see. What about this, though? What if we returned some sort of salt? Not necessarily our salt, but some salt. That allowed the second one, because here I'm saying we just changed the algorithm. But what if you got a temporary salt that thus forced you to rehash your password? And then we had the algorithm. Ooh, but then we'd need to know like 20 different salts so that we could alternate them. Like, yeah, that's probably not effective. Yeah. Okay. I think I'm going off the deep end here, trying to justify having this secondary password hash. Like, that's gonna make this much more secure. The security is coming from the multiple factors, right? I think I'm getting a little lost in the sauce here. Okay, but I still like this idea of we send our password again, and then this is where MFA is proven, right? MFA determined. We verify the password again, and we verify code. Now, this is still not stateless because we have to know which code we sent the first time. We send the code the first time, right? And then we verify the code. And part of me feels like we should be able to just generate a code with a username and nothing else. But that seems like a low bar, right? Because then anybody with your username can just be, well, I guess already too, right? Like you say you lost your password, right? You say, I've lost my password. And then you can send a code to your phone in order to get into your account on a lot of services, right? So like, that's another one where I'm not sure, like, okay, so this one is the real one where we log in, right? Because you need to know the code. And then login part one is really more of like a generate text code. All right, and generate text code. I don't know if it actually requires the password or not, if there is value in that, or if we can just generate the text code anytime we want, and then it takes a password to actually log in. I kind of like this though, using the password to prevent it a little bit. Okay, so these are our two methods. We generate a text code, and then we log in using the actual password and the text code. The verification happens twice, which is computationally intensive, but it lowers the frequency with which an attacker could like really harass somebody just by knowing their username and sending text codes. And I guess we could put a limit on that, but then like you're still screwing somebody over, right? So it's like you need a password to get the code, and then you need the password and the code to actually log in. Okay, this is good enough for now. I think that makes sense. I think that's coherent. Now, where were we? What was the next thing? All right, as I think about this, I think I'm going to keep on going with this notepad for a little bit, and then maybe later I can convert this into the diagram that I want it to be. Honestly, I'm going to need multiple diagrams, right? I'm going to need something to show the use cases of how this is used, and then I am going to need this deployment diagram showing how everything connects and who relies on what. Okay, next thing I want to look at is, okay, so I'm trying to imagine, I understand like the key generation itself, right, is going to be a lot of management of keys. But we don't actually have to manage those keys closely at all, right, like in any central database, because we generate the keys, or the client generates the keys, and then the client is in charge of like keeping track of the keys. And then the server really only needs the keys that the client brings in, at least in this Kerberos design, right? There's no like central key management that's going on here. It's the key management itself is distributed amongst the clients. But there must be some sort of key management chaos going on in the background here that must be centralized, because they start off already with those keys. And obviously, in whatever design I do, there's not going to be the need for a manual element for someone to come in and like put in all these keys. So I'm wondering if it makes more sense that, you know, there is going to be some central manager or orchestration going on that is creating all of these containers. And I think Kubernetes provides a way to populate secrets on devices. It's probably a rudimentary question, but let me just see how this works. There's a secrets manager. Secrets. Yeah, look at that. A password, a token, or a key. Created independently of the pods that use them. Ooh. A secret visible to one container in a pod. Another application uses service account. Automatically enabled authenticator that uses signed bearer tokens to verify requests. See, signed bearer tokens. Bearer tokens are mounted into pods in well-known locations and allow in-cluster processes to talk to the API server. Private or public keys used to verify service account tokens. Okay, so Kubernetes has this fancy way, right, of distributing private and public keys to different devices. And then we manage certificates. Okay. Okay, right. So the first the first thing that comes to my mind. Let me talk through this a little bit because I think I'm thinking a little bit more than I'm talking here. So the first thing that comes to my mind is instead of distributing these keys, right, we could do asymmetric keys, right? And each server could have its own private key and public key. And then if we really did need to create a symmetric key for encryption, we could do, I don't know what the RSA equivalent of like the Diffie-Hellman exchange looks like, but right, you can use your private key and the other person's public key to generate a shared key that then you guys can both use together to communicate privately. I know RSA has a version of that too. I'm not sure what that protocol is called or how the exchange works, but I know it exists, and I think that's what they're talking about here with OpenSSL communication, right? I think that's what OpenSSL already uses. And so there's some business here of like, without actually distributing these private keys to different people, we could still, end up at a solution where everybody has their own, like I was saying, every combination of two machines could have their own symmetric key combination. And I think those asymmetric keys would be a way to do that, where again, we don't actually have to centralize the key management for all of this, or the symmetric key management for all of this. Now, then we end up at a weird situation of, but you would have to centralize all of the public keys for every machine. And I also want to address it. We can't just use secrets to distribute these keys, or at least not in the way that I'm understanding it here, right? Kubernetes has a way of, creating and managing these secrets, but it's not like you can generate 1,000 secrets automatically at runtime constantly, or at least that's not my understanding of how this is built. Like the idea here, it seems is like, where was the secrets? Is that back again? is like you're predefining secrets that are available to multiple devices, like environment variables, right? And I don't know that you want a secret. Yeah, see, I don't know if secrets is necessarily what we're using here. Then you need your own RBAC rules to understand secrets, you know. But this service account tokens business makes sense to me, right? It's like there's already an underlying framework built to proliferate private and public keys onto every container running in your cluster. And I think the first, you know, I talked about centralizing the public keys for each container, but that's not what we do on the internet, right? We have the PKI, we have public key infrastructure, we have certificates, right? And we have a certificate authority. Is there PKI integration already for Kerberos? I mean, that seems like I don't think I jumped through too many hoops to get there. This is comparing them. I don't think that's what's going on. These are acting like they're two different things, but that's not true, right? Hold on. Within the transmitted message contains a small coded file appended with the message within the message that represents the digital certificate, and the public key is used to verify the digital signature of the signer. Once checking, since the signature was processed. This is Kerberos versus PKI. Okay. So I just want to address that. I'm not talking about competing theory, right? They're talking about like when you start a TLS connection with this server, there's some sort of public key or private key that authenticates that the devices are really the devices and authenticating each other, and that our connection is safe. But we're trying to verify the client using the device at the end of the day, right? So I mean, it's not like the client. We're not trying to authenticate a machine. We're trying to authenticate a person, right? So this is a bit backwards here. See, the KDC acts as a trust hub, mutual authentication between two parties. This is what I was talking about earlier. Okay, secret key embedded in messages. PKI supports a secure network communication between two parties via public and private. The need of a central, okay, wait, hold on. Prevents Kerberos from scaling beyond the intranet and the administrative burden for the KDC. Non-repudiation. Okay. So it's talking about why PKI is better over the internet and Kerberos for intranet. I think we're missing. Look at this. Kerberos PKI NIT. What is that? This brings some advantages, but also new risks. This presentation explains and demonstrates what is PK in it. Is it an audio? Is it a video presentation? We are still not. This is like comparing. This is like comparing and contrasting what PKI is and what Kerberos is, but that's not. There you go, IBM. Public key cryptography for initial authentication enables network authentication services to run a key distribution center on ZOS. I don't know what ZOS is. To authenticate a Kerberos client from ZOS or other platforms that use the public key authentication method in authentication service. It supports two main ways to encrypt the reply to the client, the Diffie-Hellman key exchange or the RSA method. Man, even they don't say. I guess public key encryption is just what it's called. That's that's so generic it doesn't, okay. The KDC reads environment variable setup for this mechanism. Database or key database, appropriate digital certificates. The KDC certificate, depending on how the issuing CA provides revocation information on your revocation, checking configuration varies. Okay. All right, for initial authentication. And the client keyring. Okay, I may be misunderstanding this, but what I think they're saying is that the green key and the green key only can be replaced by public keys, right? Which is not what I was saying at all. And I want to be super clear. Like on an intranet, it makes sense. Or even on the internet, replacing the green keys with PKI can establish this initial connection. Right, and then instead of locking with the green key, you're really locking with, the RSA, private key encryption, or the Diffie-Hellman exchange, right? Key exchange. That makes sense. But what I'm talking about is using PKI to get rid of the black and yellow keys in this diagram, right? The yellow key and the black key, I think, could be theoretically exchanged. And then you also, wouldn't need to orchestrate all of the keys. And then when I talk about, basically all of the servers inside both the service server and the key distribution center, all of our servers, all of the platform servers would just need to have a certificate authority, like a private certificate authority that is in charge of initially authenticating each individual server. And we can talk about how that would work, right? That's the next question is, when we create the server, when the orchestrator decides that we need to create a new ticket granting server for some reason, right? The new ticket granting server gets a private key and the public key has to go in some sort of database managed by, no, it doesn't have to go in the database. Blah, blah, blah. It creates the new, the orchestrator creates a new server, and instead of any database holding any keys, all we have to do is make sure that the public key for that server is signed by the certificate authority. And then the service server and the authentication server can all understand its validity. All right. Okay. So there's a lot of working around here, but I think what we're getting at is that there's some sort of internet-based Kerberos-like authentication system where instead of the green key, right, we have some sort of multi-factor authentication. And then instead of the yellow and black keys, we have some sort of internal PKI infrastructure with a certificate authority and an orchestrator. And then all of these communications have TLS, right? That's just part of it. right? There's some sort of generic TLS that's happening. Um, uh, and I don't know, to be completely honest, if the TLS that's happening here, like if all of these servers are actually, or all of these functions are actually by different servers, or if they have their own public keys that have to be independently vetted, probably not, right? There'll be like one interface that the user interacts with to get to all of these different services. Maybe not to the services, but certainly the key distribution center, right? Okay, so this is turning into some sort of internet thing or internet Kerberos implementation, but I kind of like that. I feel like I've already learned quite a bit here. So we have our database wrapper service, we have our authentication server. What else did I say there? We're going to need a you know what? And I wonder, do we really even need the ticket generating server? I guess if we want that to be a separate container, right? It's just another way to scale differently, right? I think at the end of the day, that's the true business of separating these. You don't have to separate these servers. There's no need behind it. But the authentication server is going to scale at a different rate than the ticket granting server. And thus, if they're running in different containers, you have that control. I think that just makes sense. Okay, so let's say Kerberos is open source, right? Like everyone knows what it is. This isn't like I'm not stealing this, right? What is this? Developed by MIT. Public version. Okay. All right. I mean, it must be. Wikipedia is telling me what it is, so the design at least is all right. Okay. So let's say we have an authentication server. Let's say we have a ticket granting server. Okay, this login is going to return some sort of token. We'll say session token. And this is going to take I guess, yeah. It's not a session with a server. What do they call it? Like a TGS session and then a server session. All right, TGS session token. And then the ticket granting server, you can pass in a username and you even need a username? I think you do. Username and a TGS session token. And it provides a session and service. I don't think I should use the word session here. Initiate service session. Here we go. And we verify TGS session token. And then we return a service session token. And then there's a service server down here that is doing you maybe also initiate service session, I don't know, but you pass in your service session token and we verify the service session token. Okay. Beautiful. This looks good. My next question is, or I want to capture that PKI business I was talking about. So, so the authentication server, I should say, has public, private key pair. All of these, and then what we've also talked about here is there's some sort of orchestrator. is in charge. I don't know, scaling, deployment, right? There's something running this whole business, and then there is a certificate authority, an internal certificate authority. And we'll have to talk about how the orchestrator, makes these changes. But ideally, there's some sort of host name, public key, internal certificate authority. That is, I wonder if the orchestrator itself could be the internal certificate authority. Whoa, that makes it easy, right? The orchestrator is the certificate authority that signs off when they create a new session. And everyone just trusts this certificate authority. Oh, that's so cool. Did I spell this wrong? Yeah, I missed an I. Okay. Internal certificate authority in charge of scaling deployment. Our single point of failure. It's completely off the grid. No, I don't know if that's true, but this is pretty nice, right? And it needs to know. It needs to trust the internal certificate authority. Wow. And then even there, these APIs could be through our internal certificate authority. I like this idea of using a private PKI infrastructure to kind of establish connections between my own devices. Okay, one thing I am curious about though, hold on, and this is something I didn't talk about earlier. I didn't realize earlier. I'm saying like we're going to change out the black key for this RSA public key encryption, but that public key encryption could be it could be a handshake, like it could be multiple messages. I mean, the value of the symmetric key here is that there's no overhead. You're encrypting you're sending one piece of information, and you get that dual authentication. Right. I mean, I'm pretty sure the Diffie-Hellman key exchange has like a couple back and forth in order to establish the key. Right. We're not going to get a couple back and forth. There's not going to be any communication directly between these two, which is valuable, right? I guess in any situation, like if it is one-way transfer, right? Like this, and we're just sending one thing. Like if the ticket granting server wanted to send the service server one piece of confidential information and we wanted dual authentication, we could always encrypt the information with our private key and with their public key. We could always do that. Send it, and then the service server would know to decrypt with its private key and then with the ticket granting server's public key. So we could still get that functionality, even if that's not how RSA key encryption works. Maybe that is how RSA key encryption works. I don't know well enough. I thought it was more like the Diffie-Hellman thing, where there's like they're taking advantage of the exponents and mods, and I probably shouldn't talk too much about that since I don't understand the implementation. But that should be there. Okay. Okay, I don't see any glaring holes in this design that's coming together. Maybe as I actually work through the individual use cases, we'll run into some more issues. But this orchestrator, I think, is, instead of having a database anywhere, we can just have whoever's deploying these servers be a certificate authority that is, granting them that level of authority. And then everybody kind of just trusts the certificate authority. I like this because it means everybody has their own private key and nobody has to share public keys outside of, sorry, of course you have to share the public keys, but like none of the private keys ever have to be shared. Everybody has their own private key. Yeah. On top of TLS, I mean, that's got to be very secure. Right, all of these are, of course, under, there's a TLS session happening. Okay, I think this is good. I think it's valuable. Let's see, what am I missing here? What else do we need to do? I think maybe we can stop here today. This is already a lot of information. I gotta find a way to get this into into my UML server diagram. I mean, this is just sad, right? I was expecting to work mainly on here, but that's all right. The notepad has come in handy. Maybe in the next video we can really try and get this displayed graphically somewhere. And then I think I want one of those deployment diagrams, and then I want a use case diagram for the entire logging in procedure. And then we never crack the surface on, is this LDAP? Is that, what kind of authentication is required for this communication? Yeah. I also think that this internal certificate authority and this could scale very well. I don't know if our platform will need multiple orchestrators. That seems kind of wild to me. If the orchestrator would also need to horizontally scale. Because I'm not imagining that it does now. But like, I'm sure on large enough systems, even the orchestrator needs to scale. If that were the case, if we had multiple orchestrators, we would still need one internal certificate authority. That way, servers created by different orchestrators could still communicate and trust each other. So then I think we'd have to use the secret, right? We would need our orchestrators, however many there are, to share that secret so that they can still, bless the new servers that come out with their certificate. All right. I'm gonna stop there for now. I think this is coming together. I mean, this is an interesting little design here. I'm surprised there's not more information on. I didn't look that up, but I wonder if there is more going on here with single sign-on. Developer's guide to auth. Let's see. Let's check this out. Same sign-on. There we go. This is exactly what I was talking about earlier. That LDAP seemed like something for same sign-on. Using cookies. A common DNS parent domain. See an authentication token seamlessly passed. Single sign off. Well, that is a huge glaring hole. I can't believe I didn't think about that. We're going to have to. I was just imagining, the key will eventually expire or the tokens will expire. But how would the tokens expire? Oh my gosh, I didn't cover that at all. Okay. OpenID. Okay, common configurations, Kerberos based. This is definitely what I'm doing here. Yeah, definitely. Okay, smart card based. Didn't think about that. Didn't get that. Oh man. Integrated Windows authentication, security assertion markup language. Okay. Emerging configurations. Mobile devices as access credentials. user security information between an identity provider and a service provider. Okay, maybe I should look more into these next time too. Okay, so let me write that down, and then I'll probably end the video there. So next time, what should I write? Next time, we want diagrams for real. We want to look at non-Kerberos based designs. Maybe I'm missing something there that would be better understood. I don't want to scrimp on the research. Okay. Single sign off and token expiration, right? We need to look at both of those, how that works in the design. Okay. And then the database. What is our database? Is this just a homegrown database? Is it LDAP? Does that work? Okay. Beautiful. Okay. I think we need to cover this. Deployment and use cases. All right. Next time. Excellent. All right. I'll find a way to do it. All right. Thank you, everyone. Go first video.